Hello and good morning, good afternoon, my babies. I'm sorry I won't be in today. The lady, my wife is sick, so I got to help her at home, and then I got to take her to some appointments that she's not able to drive right now because she's on medication. So everything should be fine. I got to help her out today, so I won't see you all. Uh, I'll miss you all, and I can't wait to see you all on Monday. But I'm going to go over the same notes that we went over yesterday in the practice. That way, you guys can have it in the teams if you need extra help and the teachers aren't able to, the sub's not able to help you. But coach should be there for periods 2 through 6, and he should be able to help you. And then Miss Escobar should be there in seventh to help you all out. Okay. If not, watch the video and then get the notes from yesterday. Also, anybody that was absent yesterday. So for today, we're going to look at graphing linear equations. These are word problems. They're a little bit more complicated and they're more complex because now we have to read through the problem and then identify the things that we need and what is it that it's asking us to solve. We also need to write the equation and we need to graph and then we need to answer some questions. So there's quite a few pieces to each one of these problems. Let's take a look at the first one. Number one right here. Georgie joins a gym. She pays $25 to sign up and then $15 a month. Now, what I had mentioned a couple days ago when we did the graphic organizer is how do we know where to start when we have slope intercept form? Okay, so slope intercept form is y equals mx plus b. And I told you all, start with the y intercept, and this is going to be your starting point. You get your first point, and then you use your slope to get your second point. So in this sentence or in this problem, what is Georgie going to do first? Where's her starting point? Is she going to start by paying $25 to sign up, or is she going to start by paying $15 a month? Well, before you go to the gym, you got to sign up first. So her first step is going to be to sign up. So this 25 represents our y-intercept. I want you guys to identify the y-intercept and the slope for each problem statement. So this little square right here, each of your problems, I should see y-intercept, and then I should see where you identify the slopes. Okay, if 25 is the y-intercept, this has to be the slope. And she's paying $15 a month. It's going to add on to her cost, so it's going to be a positive 15. As far as the equation, now that we have identified the b and the slope, we can simply write our equation as y equals 15 times x plus 25. So your second part is you will have to write your equation in this box right here. As far as the equation, what we're looking at is we say that y equals 15 times x. In this case, it's $15 per month. So x represents what? X is going to be months. 1 month, 2 month, 3 month. We can substitute any number in here for x, and that's going to give us an answer to how much our total cost is. So if x is the number of months, then y must be what? Y has to be the total spent or total cost. Okay. So now we're going to graph, which we should know how to graph already. We start with the y-intercept, plot our point at 25, and then we're going to use our slope to calculate. Before we graph, first of all, there's no numbers, so we're going to have to fill in our own intervals or our own numbers. And then we also need to identify. So this is part of your assignment too. I need you to identify what are we graphing. What we said on the bottom is number of months. And then right here, it's either total cost or total spent. And we need to fill in some numbers. So on the, oh, what happened to my months? Let's put those back. One, two, three, 4, 5, 6, 7, 8. Because months usually go in order. We usually count the months 1, 2, 3, 4, 5, 6. I'm going to number these 1 through 10. But there's not enough squares here to fit. If we give them each an amount of 1, they won't fit because we need to start. Oh, that's where my months went. I'm on the wrong problem. Okay. My bad. Let me fix this. I'll fix the other one. Total cost. Okay. And then there's the months I was looking for. But we are going to label these the same. 1, 2, 3, 4. I'm sorry on your sheets that it's so small. Next time I'm not going to print them so small. I didn't like the way they came out. And here, if we give each square a value of 1, we won't fit all 25. So what I'm going to do is I'm going to give each of these a value of, I think 10. Let's give each square a value of 10. So each little square is worth $10. We're going to plot. We're going to start at 25 as our y-intercept. So 20 and 30. So 25 would be somewhere in the middle. And then we're going to spend $15 each month. So after the first month, we're going to go up 15. 5 and 10 is 15. Remember, each one of these squares is worth 10. So that's 10 plus 5 is 15. 10, 15. 15. At 4, we're going to go up. So 1.5 squares is equal to 15, basically. Okay, and that's our plot. Those are our coordinate points. And now we're going to plot a straight line. And it's going to keep going until as long as she has that membership. What we're going to do is, I think first, third, and fourth, I had you guys do this, but I'm going to change my mind. And if you guys, the earlier periods already did it, that's fine. But if you haven't, don't worry about filling up the right. I didn't kind of like the way these were set up. Okay, so now let's interpret the graph. What does this actually mean? We haven't talked about this yet, but some of these points, what do they actually represent? Well, each point on this line represents a solution to this equation. Every single one of these points, each point on the line represents a solution. Let me rewrite solution. To the equation. So what does that mean? Well, let's say when x is 3, at month number 3, she's going to have paid $70. So when x is 3, y is 70. Another example is when x is 5, y is 100. So those numbers make this equation true. They will make it their solutions or their answers to this problem. So when we look at this, it's kind of like, oh, this is a problem to solve. Y equals 15, x minus plus 25. If we substitute 5 in here, we'll get 100. If we substitute 3, we'll get 70. Okay, so these represent, each point represents a solution to the equation. Let's take a look at this question. I do want you guys to answer these questions. So read the graph. How much will Georgie, let me read, hold on, sorry, I'm sidetracked. How much will Georgie have paid if she used the gym for 5 months? Well, we already said that. At 5, it's going to be 100. So we can get it from the graph right away. Now, in some of these problems, when you're working them, you're not going to get the answer that they're asking you. It might be off the graph, or it might not. The graph might not have been big enough for you to get all the answers. So another way to do it is algebraically. Okay? That means we're going to solve the equation. Y equals 15x plus 25. Where we're going to say it's asking for 5 months. And we know x represents months. Remember, x represents months. So we plug in the 5 or substitute the 5 for x. And then that's going to equal 100, which is the same answer that we got out from looking at the graph. So in this one, it's very easy visually to see every month how much she's going to wind up paying overall. It's basically 25 plus 15 plus 15 plus 15 plus 15 for every month. And that's kind of how an equation in real life looks compared to what we've just been graphing numbers, coordinates, and looking for slopes. They've been random equations that don't really mean anything. But now we can say when we put meaning to it, we identify the x and y to mean some kind of variables. Now it's actually something that's actually kind of useful to us. Okay, I'm going to walk you through problem number 2 as well. And then you guys need to pick 3 problems to complete by yourself or with your group from problems number 3, 4, 5, 6, 7, 8. You guys need to pick 3. I'm only going to check 3 that you complete. You guys will pick which 3 you want to complete. Okay, I would read through all of them very quickly and then kind of see which three seem like the easiest to me and then do those. But I'll leave it up to you guys to decide how you're going to do it. Okay, so this one, let's kind of. Oh, this one's also a money problem. So Edwin has $50 in his bank. He starts spending $250 a week on snacks. So in this case, it's not going to be months. It's going to be, we're going to measure this per week. So our X value is going to be weeks, and we're still going to be looking at total spent. Okay. So let's identify. I told you I wanted you to identify the y-intercept. So in this case, his starting point is his bank account. So the y-intercept is going to be 50. Our slope is that he spent $250 a week. Now, when you spend money, is it a positive or a negative in your bank account? You're taking money out, so it's a negative. So our slope is negative 2.5. And don't forget the y equals. Okay, so that's our equation for this equation. That's our equation for this problem. This equation represents, we can find the solution for how much money he's going to spend each week. As far as the graphing goes, I'm going to number the weeks 1 through 5. And I'm going to number his account in $5 increments. $30, $35, $40, $45, $50. $25, I kind of skipped it because I thought I was running out of space, but then it looks weird having a blank. So we're going to number these. Each little square is worth $5. Now in this one, he's going to start at 50. That's his first point. He's got $50 in his bank account. And because it's negative, we're going to go down 2.5 until the right one. So if each one of these squares is 5, $2.50 is half of that. And then we go over 1. Then another half and over 1. Then another half and over 1. Okay. And every step we're going to go down half of a square and over 1. Okay. Because remember, we're trying to indicate that we spent $2.50 every week. So as we go down, one square is worth $5, half a square is worth $2.50. That's why I'm going down half a square. And eventually, obviously we're running out of space here, but if we kept graphing, well, not only do we see that the slope is negative, which makes sense because we're running out of money, eventually this graph would go to some point where it's like, we'll figure out how many weeks does it take for him to get to $0 in his account. Okay, remember, we're not going to use the write it anymore. For the earlier periods, if you started it, I appreciate you putting that effort, but I'm not going to actually check these, so don't work on these anymore. But we do have to answer these to read the graph. After how many weeks will Edwin run out of money? Obviously, we don't know because we've run out of graph and we can't be precise if we just kind of estimate it. So what we're going to have to do is use it solving algebraically using the equation to solve. Okay, so how many weeks will he run out of money? When you're out of money, that means that our y is going to be at 0. So when y is 0, what is our x equal to? How many weeks is that? We'll have to solve this by bringing 50 to the other side. Then divide, x. Divide, that's another x. Divide by negative 2.5. Those cancel. And we wind up being, I'm going to come up here, x is equal to 50 divided by 2.5. I think that's, I don't know, 20? Let me get my calculator out. 50, negative 50 divided by negative 2.5. It's, I weigh 125. 50 divided by 2.5 is 20. I must have done something wrong. 20 sounds right. 50 divided by 2.5, 20 weeks. So at week It will take him 20 weeks to spend all his money. I wish, man. I spend more than two. I probably spend $4 a day on snacks, a day, not a week. Okay. Good luck. I will see you all on Monday. If you'll have questions, ask Coach or ask the sub. Maybe they can help. They will have the answer key if you want to check your work with them. Okay. Good luck today. I'll see you all Monday. Have a good weekend.